MedCram.com.
Welcome to another MedCram COVID-19 update, and COVID is on the upswing. Here you can see wastewater levels across the United States, and we are at one of the peaks here that would equal any one of these other ones. Wastewater is more accurate because it doesn't depend on the amount of testing that you're doing, because you're looking at a sample in real time against some known historical values. In terms of the United States, you can see that the states in red are where it is the highest. I will say, however, though, that hospitalizations are definitely down compared to where they used to be when we were dealing with these peaks. And so that's good news, although I am starting to see some people being hospitalized once again with SARS-CoV-2, even in our intensive care unit. And it really brings up the question about longevity. Longevity is this thing that we're all seeking. We want to live long and we want to live healthy. But you know, the enemy of longevity is actually chronic disease. And the types of diseases that I'm talking about are things like heart disease, diabetes, obesity, dementia, inflammation in general, long COVID, cancer. These are the types of things that can sink your ability to have a long and fruitful life. And it's interesting because these are the risk factors that put people with COVID into the hospital and make these people sicker. People with heart disease, diabetes, obesity, they're going to have a harder time with SARS-CoV-2. I find it really interesting that chronic disease is actually hurting us in terms of the population in more than one way. All of these diseases have something in common. They are all emblematic of mitochondrial dysfunction, the powerhouse of the cell. Inside of most of your cells, there's these little organelles called mitochondria, and they burn fuel in the form of glucose, fats, proteins to make energy and carbon dioxide. And just like an engine in your car, which makes locomotion and needs a good cooling system, otherwise the engine will become inefficient and shut down, the mitochondria also makes heat in the form of something called oxidative stress. Now, if that oxidative stress is out of control, it's going to make your mitochondria less efficient, and it's going to make less energy, and it's going to cause problems and diseases. And it's those diseases that cause mitochondrial dysfunction. But scientists are finding out that melatonin is a substance that is made on site. It's sort of like a cooling system, and that the higher the levels of melatonin, the less oxidative stress that you have. In fact, melatonin is a cooling system that allows your mitochondria to work more efficiently. Those of you that have been following us here on MedCram know that there's been exciting research that shows that there may be a way to actually improve melatonin in your cells. That melatonin is what? It's something that doesn't require a supply chain. It's something that's free. You just have to go outside and get it. And I think this is really important, especially when we talk about pandemics, because supply chains can be hurt by pandemics. That's right, it's sun, but not just any portion of the sun. Specifically, red light and near-infrared light is now being shown scientifically to have an effect on the mitochondria, that it tends to produce melatonin, which is the most powerful antioxidant actually in the human body. It's even more powerful than glutathione. Here's an excerpt from a paper by Russell Ryder and Scott Zimmerman that was published in 2019, ironically 1 year before the pandemic. They say here, it has now been shown that the mitochondria produce melatonin in many cells in quantities which are orders of magnitude higher than is produced in the pineal gland. This subcellular melatonin does not necessarily fluctuate with our circadian clock or release into the circulation system, but instead has been proposed to be consumed locally in response to the free radical density within each cell, in particular in response to near-infrared light exposure. Now, this is important to understand because infrared light is something that you can't see. It's beyond the spectrum of red, just like ultraviolet is on the other end, the high frequency end, beyond purple. So think of this as a keyboard. There are certain frequencies that you can't hear above the highest point and below which the lowest point. Well, this is the same sort of thing with infrared light. We need to have this light be able to penetrate. How is this going to happen? The type of area that we're talking about is this area down here in the red to infrared light. And this can penetrate solid objects better than this other type of light up here. If it doesn't, it's not going to get to that mitochondria. Let me show you again here what I'm talking about. This is a photograph given to me by Robert Fosbury, who's an astrophysicist at the European Space Agency. He's got a near-infrared light source behind his hand and a near-infrared filter in front of his hand, actually photographing this. As you can see, these photons of light can actually literally pass right through the entire hand. And you may notice something here. there's something missing that you would expect to see here. What you're missing is bone. This type of light can actually penetrate through bone. It's kind of like when you pull up to a stop sign and there's another car there and it's playing its really loud music. What you're hearing mostly is the low frequency sounds, and that's exactly what infrared and red light is in the visual spectrum in this case, is that it's very low frequency light and it's able to penetrate through solid objects. It can penetrate deeply into your body and stimulate the mitochondria to make melatonin. This is what they are actually finding out. The other thing that's really interesting about this as well is that infrared light happens to be something that is reflected highly in grass and leaves of trees. This is an infrared filter, once again, from Bob Fosbury, showing a lot of reflectivity here in terms of the trees, the grass. Notice that the water is very dark, and that's going to become important because water seems to be the great absorber of infrared light. So let's review again. We got near-infrared light that's coming in, and it's penetrating through the skin, and it's scattering, going to the mitochondria, and there it's making it more efficient. It's cooling the engine down, making it more efficient, less likely to seize, so we get less oxidative stress. We get more output from the engine. That means more ATP. That's the energy that comes out of the mitochondria. There's more metabolism occurring, so a higher production of carbon dioxide, and because it's using fuel, you're going to get lower blood glucose. Is there actually evidence for this? This is from Glenn Jeffries' lab, where they took 30 students and they exposed them to 75 grams of glucose. In a randomized controlled trial without them knowing, on their back, they exposed them to red light from 15 minutes versus placebo, just on their back, about a 2-foot by 2-foot section. And they found that there was a 27% reduction of glucose in the blood. And they said, wow, what's causing this? And they checked on those subjects for exhaled carbon dioxide, and it was higher in these subjects that had lower glucose. If the mitochondria seems to be the place where this is happening, the tissue in the body with the highest amount of mitochondria is the retina. And that makes sense because there's a lot of transportation there of signals going on in the retina. It's highly metabolically active. This goes along with the mitochondrial theory of aging, which is that after about 40 years, there's about a 70% decline in ATP production, leading to visual problems in the elderly. Well, they did an experiment where they took elderly people and they exposed them in the morning to red light for about 3 minutes, and that was enough to rejuvenate the mitochondria so that for a week, there was a 17% improvement in visual acuity. Again, this was published out of Glenn Jeffries' lab, and it was in a randomized controlled trial. What about some other data? This is a great study that was done at Oxford where they took people to give blood tests, and in the previous 7 days of drawing that blood, they found that every single hour of increased sun, not temperature, but sunlight, led to improved insulin sensitivity and decreased triglycerides. This wasn't like sun led to more exercise outside, and that's what did it, because it was not based on temperature. And the things that get you outside is not just sun, but also temperature. If you want to get even bigger than that, this is a study that was done in Sweden, published at the Karolinska University Hospital. 30,000 people, 20-year follow-up, massive study, published in March of 2016. And they divided these people here into 3 groups: those that avoided the sun, those that had moderate sun, and that had most active sun exposure. And you can see here that cardiovascular disease went down as sun exposure went up. Cancer death rates went down, and other non-cardiovascular death went down. In other words, there was a dose-response curve. Now, this study was repeated again in the UK with 10 times the number of people, and they found exactly the same results. 300,000 people. Follow-up showed that as well. So it should make sense that if you're getting outside and you're getting near-infrared light, that getting out into green spaces should do that, because we just explained that green spaces reflect infrared light. And they found this exactly the same thing. This is the University of East Anglia in the UK, meta-analysis of over 140 studies showing that the benefits of the great outdoors was that for diabetes, there was a 28% reduction in incidence. Cardiovascular mortality dropped by 16%. Overall mortality decreased as well. And they said in the paper, we found that spending time in or living close to natural green spaces is associated with diverse and significant health benefits. It reduces the risk of type 2 diabetes, cardiovascular disease, premature death, and preterm birth, and increases sleep duration. People living closer to nature also had reduced diastolic blood pressure, heart rate, and stress. In fact, one of the really interesting things we found is that exposure to green space significantly reduces people's levels of salivary cortisol, a physiological marker of stress. The data seems to be overwhelming, such to the point that even the dermatologists in August of 2024 in the Journal of Investigative Dermatology are saying maybe it's time for a rethink. That a number of societies have made statements recognizing that sunlight has beneficial effects that should be considered in formulating policy on sunlight exposure and highlighting the necessity of carrying out further research in these beneficial effects. We should take note. And I tell you, I did take note. And you're probably asking, why is a pulmonologist interested in sunlight exposure? And it's because of what happened 3 to 4 years ago when the pandemic started. I just did not know what it was that we needed to do with these patients. So I started to study, I started to learn, started to realize that in fact, the SARS-CoV-2 virus hit something called the ACE2 receptor. Well, we know it's a receptor, but many people don't understand that the ACE2 receptor is also an enzyme that is responsible for balancing oxidative stress in the mitochondria. It balances this. In other words, if you knock out the ACE2 receptor by binding it to a SARS-CoV-2 viral particle, it's not going to be able to do its work. And this is the same as heating up the engine or having your engine going up a hill. So this is what happens. SARS-CoV-2 comes in, binds to ACE2, and you get a knockout of ACE2. And so now you're climbing up this hill with this engine perhaps that's not cooling very well, and it's going to be a workload to go up this hill that's called COVID-19. Well, what are the things that can cause problems as you go up is when your engine is not being cooled. That can cause steam to come out of your car, for it to overheat. And guess what are the diseases that we saw that were associated with COVID-19 mortality? Heart disease, diabetes, obesity, dementia, inflammation, cancer. Exactly the same diseases that have as its roots mitochondrial dysfunction. One of the things that we saw early on, and we even did a video on this, got a lot of views, that people with vitamin D levels that were high had good survival. People with vitamin D levels that were low had low survival. And we started to say, well, maybe it's the vitamin D. We need to give vitamin D. Now, look, I believe in supplementing with vitamin D. I do it myself. I do believe that there are actual benefits from vitamin D, and there's been papers that have actually shown this to be the case. The problem is we're not seeing the same magnitude of benefits that we were seeing in terms of these retrospective data. So we would do randomized controlled trials, and we would show there might have been a modest improvement in survival. And so what I started to understand and started to hypothesize is that vitamin D is not the thing that's doing the heavy lifting in COVID-19, but rather vitamin D is a marker for sunlight exposure. That something else in the sun, other than the ultraviolet B radiation making vitamin D, is doing the heavy lifting. So in comes this paper that was published in January of 2021. And it looked at the surge dates of COVID-19 in the autumn of 2020. And interestingly, it started in Finland and it marched right down the continent by latitude until it ended up in Greece. It had nothing to do with temperature. It had nothing to do with humidity. So these were not correlated. It was latitude strictly. Another study that was done out of the University of Edinburgh, this time looking at the United States, they found that as you went from north to south in terms of latitude, mortality went down. Repeated the study in England, found exactly the same relationship. Repeated the study in Italy, found exactly the same relationship, causing them to say, it suggests that optimizing sun exposure may be a possible public health intervention. Given that the effects appears independent of a vitamin D pathway, it suggests possible new COVID-19 therapies. I also had the privilege of teaming up with Margaret Scutch, who has her doctorate in geography, and we looked at the data across the world, and we found that in countries where 50% of the population is overweight, we also found a connection to latitude, and we published that paper. It's not just COVID, it's actually also influenza, and I would suggest it's just about every single infectious disease and probably more. Even at the Harvard Kennedy School, when they looked at influenza and they combined it with solar radiation data from the National Solar Radiation Database and looked at influenza from the CDC, they came to the same conclusion. They said that we find that sunlight strongly protects against getting influenza. In fact, a 10% increase in relative sunlight decreases the influenza index in September or October by 1.1 points on a 10-point scale. So clearly, what we're looking at here is that sunlight is beneficial. So why not use it in COVID-19? There's a study that did that too. In Brazil, what they did was they looked at the specific component of sunlight which we believe should be working in the mitochondria. That is infrared light. And they took 30 inpatients that were not sick enough to be in the ICU, but sick enough to be admitted to the hospital between the ages of 50 to 80. They did an intervention over 7 days where they randomized them and blinded them to getting 940 nanometers of light, that's the infrared spectrum, for just 15 minutes a day. And then both groups got conventional therapy. So what did they find? In the group that got 940 nanometers of infrared light for just 15 minutes a day, what happened? Oxygen saturation improvement went up by 9.4% in the intervention group versus the control group. That was a p-value that was statistically significant. There was more tidal volume. The inspiratory pressure, the expiratory pressure, the respiratory rate, the heart rate, all of these were superior to the control group. Even the amount of white blood cells that were there to fight the virus actually went up in the near-infrared group and actually went down in the control group. And here's the big kicker, folks. These patients that got near-infrared in a randomized placebo-controlled fashion were discharged from the hospital a full 4 days earlier than their counterparts here in the control group. This was the piece de la resistance for me. And unfortunately, by this point, many patients who had come into the hospital were no longer coming in. We had had the big wave, and now things were declining in terms of hospitalization. But I vowed that if a patient ever again came back into the hospital that I could do this type of treatment on, I would do it. But this type of jacket was made for this research study. This is not something that you can go out and buy and use in a hospital. And so, just about 6 months ago, I had a patient that came into the hospital with COVID-19 that he had gotten a number of days before, but he kept getting worse. On the day of admission to the hospital, he required 4 liters of nasal cannula. That's something that looks like this, that just fits under the nose. And he was in the hospital for 2 days. During those 2 days, I wasn't called to see him because I was in the intensive care unit, and they only call me when patients need to be intubated or need advanced airways or things of that nature. And during that time, he was getting all of the solid treatments, solumedrol, azithromycin. They even took my advice not to use Tylenol to suppress the fever. But despite that, his oxygen requirements went up to 10 liters oximizer. Finally, on the day that I saw him, which was right here, I went into his room. It was dark. It was depressing. He asked me how long he had to live. We needed to do something differently. So what I did was I got together with our respiratory therapist, our charge nurse, and we decided that we were going to get this guy outside somehow. Because on the day that I saw him, he was on 35 liters of 100% FiO2, which is a huge amount of oxygen. Despite that, our respiratory therapist was able to put 2 tanks of oxygen together so that we could get enough oxygen, not through just a high flow, but also through a mask that he would wear at the same time to get him into a wheelchair and to get him outside. And that was full light for 20 to 30 minutes. Look, if 15 minutes was good for the LED 940 nanometer, I was going to certainly make sure that this gentleman was going to get enough light. And we were going to do that on a daily basis. This doesn't prove that this works. This is simply showing a proof of concept that the data that seems to reflect that people improve with near-infrared light on a number of scales, not just on the individual, but also on the population level, it can be done in patients who are suffering from COVID-19 in the hospital. The very next day, he went from 35 liters of 100% oxygen down to just 15 liters oximizer. After that, he went down to 10 liters oximizer. Notice that the amount of time it took for him to peak was about the same amount of time it was for him to come down. He was decelerating in his illness quickly and getting better. Then down to 6 liters nasal cannula, 4, and then finally he was off his oxygen. I've seen many patients in the intensive care unit who have been on oxygen, and I'll tell you, this patient, in my mind, seems to stand out as one that was getting off their oxygen the fastest. Again, full light, 20 to 30 minutes each day, just once a day. Here's an actual photograph of what happened. This was the first day that he went out there. I got permission to take his picture. This is his daughter here. This is our respiratory therapist. This is our charge nurse. Amazing. And we could see this really amazing stuff. And so I thought in my mind that I've just discovered a brand new treatment for COVID-19. Sunlight seems to help so much. But then I was reminded of what people back in the 1800s had said. There's certainly one thing that you cannot criticize the people in the 1800s who were healthcare providers especially, and that was their sense of observation. That was something that they had a keen sense about, especially people like Florence Nightingale, who, despite the fact that she had two parents that were very well off, she decided to take the hard road and to live a life of service to her fellow countrymen, people who were dying and injured in the Crimean War. And this is what she says in terms of what her observations were. She says, of all the remedies I have used or seen in use, I can find but one thing that I can call remedial for the whole disease, and that is a profuse supply of fresh air. Second, only to fresh air, however, I should be inclined to rank light in importance for the sick. Direct sunlight, not only daylight, is necessary for a speedy recovery. Another notable health reformer, about 20 years later, said the feeble one should press out into the sunshine as earnestly and naturally as do the shaded plants and vines. The pale and sickly grain blade that is struggled up out of the cold of early spring puts out the natural and healthy deep green after enjoying for a few days the health and life-giving rays of the sun. Go out into the light and warmth of the glorious sun, you pale and sickly ones, and share with vegetation its life-giving, health-dealing power. Many of you have heard me talk about this many times, but I think it was worthwhile today to sit down and review quickly the data and why it is that we decide to do this. We are living in a time right now where COVID-19 is surging, but I believe we have the knowledge and we have the tools to do something about it. And what should we do about it? There are a number of things. First of all, at the individual level, these are things that we can take to heart. I would highly recommend that we all, each of us, get outside 20 minutes more than we would normally be expecting to do so. I think it's going to have a tremendous benefit on our health, and I think we should do it in the morning if it's possible because it's been shown to have very beneficial circadian, cognitive, and mood stabilizing qualities. Number two, our employers. People that employ people. If you want to have the best productivity and the best health, the least sick time, then you should know that your employees need a lot of natural light. Breaks outside, breaks often if they can. Making sure that people are not tied up in their offices because while there may be a short-term benefit to production, in the long term, there's going to be more turnover and that's going to cost the company. What about healthcare maintenance organizations? If they truly understood and grasped this, remember that healthcare maintenance organizations, HMOs, managed care, Medicare Advantage, all of these are institutions where they are basically paying healthcare providers a flat rate, and it's up to the healthcare institution to make sure that those dollars are stretched, that preventative medicine is number one. And imagine what we could do to chronic disease in this country if we just started an approach, just one approach out of many that could also be done, where we start to say we need to get more natural light, we need to get outside more. That's especially important in a time and space where we are now increasingly under the lamp of LED lights, which have no infrared light coming out of them, and also inside buildings that have windows that are specifically designed to block infrared light. Hospitals. Hospitals used to be designed over 100 years ago with the patient in mind in terms of getting better, in terms of healing, making sure that those patients had large windows, making sure that those patients had access to fresh air. Now hospitals are designed for economy and for delivering the current standard of healthcare for the cheapest amount of dollars. Because of the financial structure, which actually incentivizes getting better quickly and spending the least amount of money possible on patients, I think there are a number of healthcare systems that if they truly understand the powerful benefits of sunlight and natural light on the health of their clients, they would start to look at architecture and policies that get patients outside. I am pursuing that in terms of getting patients outside into the sunlight. The lighting industry, we've just talked about that. If the lighting industry knew that perhaps there could be some downsides to producing only light in the visible spectrum and no light outside of that visible spectrum, I think that they might decide that there is a market for that such type of light. And again, number 6, if governments understood this and we told our governments that we were interested in that, that might be something that would carry a little bit more weight. As it is in this country, in the United States where I am, we have bans on selling incandescent light bulbs. Now we see all these LED lights, and we're wondering now whether or not there is good scientific data to show that these lights may not be the best for our health. And I think there's more data very shortly that's going to be coming out on that topic. There is a COVID surge occurring, but let's look at the bright side, literally. It's happening in the months of the year where we have the most amount of sunlight. Instead of hiding inside as a recluse away from the sun, we should make a point of getting outside for at least 15 to 20 minutes a day. If you like this video, please subscribe to our YouTube channel. Please turn on notifications, leave us a comment. Visit us at medcram.com for continuing medical education for healthcare providers. That is one area where we need to do a good job of educating healthcare providers on this recent data and data that actually goes back quite far. Please share this data and share this video with your loved ones. Thanks for joining us.